Day 4, Thursday. The goal is to describe how air moves around the globe. Complete pages 11 through 15 of the packet. What causes weather changes? When you finish pages 11 through 15 and this video, check out these resources: high pressure versus low pressure, global winds, and weather fronts. What causes weather changes? Cloud patterns indicate the presence of weather systems, which produce most of the weather we are familiar with: rain, heat waves, cold snaps, humidity, and cloudiness. Weather systems are simply the movement of warm and cold air across the globe. These movements are known as low-pressure systems and high-pressure systems. This picture shows a simple cartoon of a high-pressure system and a low-pressure system. Remember, in a high-pressure system, dense, tightly packed air moves down closer to Earth's surface, and this dense air spreads out and away from the high-pressure system. In a low-pressure system, the exact opposite happens. Air moves towards the center of a low-pressure system, and when it meets in the middle, it rises up, away from Earth's surface. But how does air move across the globe? Global winds. Earth's orbit around the sun and its rotation on a tilted axis causes some parts of Earth to receive more solar radiation than others. This uneven heating produces global circulation patterns. You can see that radiation, or heat and light energy from the sun, more directly hits the middle of the Earth, at the equator. This same energy does not reach the poles as much as it does at the equator. This causes uneven heating. For example, the abundance of energy reaching the equator produces hot, humid air that rises high into the atmosphere. A low-pressure area forms at the surface, and a region of clouds form. A low-pressure area forms at the surface, and a region of clouds forms. The air eventually stops rising and spreads north and south towards the Earth's poles. About 2,000 miles from the equator, the air falls back to Earth's surface, blowing towards the pole and back to the equator. 6 of these large convection currents cover the Earth from pole to pole. If you look at this image, we can see the red circles. The red convection currents are at the equator, showing more heated air. This hot air rises away from the Earth's surface, and as it cools, it moves closer to the poles, where the air temperature is much lower. The cooler air is more dense and sinks closer to Earth's surface. As this dense air returns to the Earth's surface, it continues a circular pattern. These patterns are known as convection currents. Air masses. These global wind patterns drive large bodies of air called air masses. Air masses are thousands of feet thick and extend across large areas of Earth. The location over which an air mass forms will determine its characteristics. For example, air over the tropical ocean becomes exceptionally hot and humid. Air over a high-latitude continent may become cold and dry. You have probably noticed the temperature rapidly dropping on a nice warm day as a cold air mass pushed a warm one out of the way. As an air mass warms, it becomes lighter and rises higher into the atmosphere. As an air mass cools, it becomes heavier and sinks. Pressure differences between masses of air generate winds, which tend to blow from high-pressure areas to areas of low pressure. Fast-moving, upper atmosphere winds, known as jet streams, help move weather systems around the world. If you look at this picture, we can see different kinds of air masses. Maritime tropical air masses, shown in green, form above the oceans, and they're warm. Maritime means over water, and tropical generally means warm. Maritime polar air masses, shown here in light blue, are formed over water, but because they are polar, are damp and cold. Continental polar air masses are formed over a continent, or land, and polar again means they are cold. At the very top, we have continental Arctic. This air mass, shown in purple, is very cold and dry. Finally, the small orange air mass is continental tropical. Continental means it's formed over land, and tropical generally means this is going to be dry. Continental tropical air masses are hot and dry because they're formed over land near the equator. Fronts. The motion of air mass motion is usually based on the airflow in the upper atmosphere. The location where two air masses collide is called a front. With a cold front, a colder air mass is replacing a warmer air mass. A warm front is the opposite effect in that warm air replaces cold air. There's also a stationary front, which, as the name implies, means the boundary between two air masses does not move. In this picture, we can see air mass 1 and air mass 2. They're about to meet. We could have a cold front, a warm front, or a stationary front. This picture shows what happens in each type of front. First, in a cold front, cold air is advancing on warm air. Because cold air is more dense, it stays closer to Earth's surface, which pushes warm air up and out of the way. As this warm air rises, the moisture in the air will condense and form clouds. Often, cold fronts can bring rain. A warm front happens when warm air advances onto cold air. Because warm air is less dense and warm air rises, the warm air mass will slide above the cold air mass. Finally, in a stationary front, a cold air mass and a warm air mass meet, but neither air mass advances or passes over the other. The symbols for these three air masses are shown on the screen. A warm front is shown with a red line with semicircles. We can remember that this means warm front by the semicircles looking like a rising or setting sun. A cold front is shown with a blue line with triangles. We can remember the cold front symbol because the blue lines and triangles are kind of like icicles. Finally, a stationary front has characteristics of the symbol for cold front and for warm front. This is an easy way to remember both fronts are present, but neither front is moving. The motion of air masses also affects where a good portion of precipitation occurs. The air of cold air masses is more dense than warmer air masses. Therefore, as these cold air masses move, the dense air undercuts the warmer air masses, forcing the warmer air up and over the colder air, causing it to rise up into the atmosphere. The dense air undercuts the warmer air masses, forcing the warm air up and over the colder air, causing it to rise into the atmosphere. Fronts can be indirectly observed using current weather maps, which can be used to track them as they move across the Earth. Cold fronts, generally shown in blue, occur where a cold air mass is replacing a warm air mass. Warm fronts, shown in red, occur where warm air replaces cold air. Pause the video and try to find the warm, cold, and stationary fronts on this map. This map shows a cold front in the Gulf of Mexico and the Atlantic Ocean, a warm front in the Atlantic Ocean, a cold front crossing through California, Nevada, Utah, Colorado, and Wyoming, and two stationary fronts, one in Washington and the other cutting through Nebraska, Kansas, Missouri, and Arkansas. Let's check for understanding. Summarize each of the following in your own words, or an image if you'd like to draw. Global winds, air masses, cold front, warm front. 36. What are the differences between a cold front and a warm front? 37. Examine the following weather map and answer the questions. What is expected to occur in Oklahoma on April 2nd, 2020? Examine the pressure systems on the map. How does this account for the precipitation from Texas all the way north to Minnesota? Identify two other trends on this map. Explain these two trends in terms of pressure, precipitation, and air masses, or fronts. Some things to think about. How do temperature, wind, humidity, and pressure relate to fronts. Search on your own for examples and explanations of fronts. If you find something good, send it to me on email or Third Remind.